Hey guys, welcome to the next video on stereochemistry. This one is going to be going through a specific example of RNS just to help you guys get more practice with it. So if you want to stop this video now and try it yourself, please feel free to do so. Okay? So I picked this example specifically because it's a little bit on the more complex side and I want to prepare you guys as best as possible for some of the harder stuff that you guys can encounter. Okay? So I definitely want to get you guys ready for that. So I picked one that's a little bit on the harder end. And so we're going to assign RNS configuration to it, and the first thing we need to do this is to determine where is the chiral carbon, or if there are more than one chiral carbons. Okay, so let's just start from here. Is this carbon chiral? Well, it has a sulfur group, some carbon chain coming off the other end of it, and two hydrogens. So because it doesn't have 4 unique substituents due to those two hydrogens, it's not chiral. What about this one? Same deal as the previous one, two hydrogens, those aren't unique, so it's not chiral. In this one, we have two methyl groups, so it's also not going to be chiral. All right. What about this one? This one has this CH2OH, this methyl group, a carbon chain coming off the left, and an aldehyde coming to the top. So all four of those are different, and so that is going to be chiral. And this carbon right over here, well, it's not sp3, right? One of the requirements is 4 unique substituents, then it has to be sp3 and tetrahedral. It doesn't have 4 unique substituents because we have only 3 substituents, and it's sp2, and it's not tetrahedral. So only our red carbon right there is going to be the chiral carbon. Okay, so this is a little bit of a larger molecule and not as straightforward. Okay, and so the systematic way of going about this is to draw out all 4 substituents separately. So I'm going to draw this. Our red carbon, let me just make that smaller. The carbon that I had, our chiral carbon that I drew a little red dot over is the one that I just drew right there. Okay, we're going to draw all of the substituents. And this carbon here with an aldehyde and this H. So that's the substituent coming off the top. Now we have, let's draw this other substituent. Nope, that was a mistake. And so now I'm going to be drawing this carbon chain. Right, it has 3 carbons right there. One of them is methyl coming off. Now the next substituent that I'm going to be drawing is the one with the CH2OH. And the last one is going to be that methyl. Okay, and so how do we do this systematically, right? Well, when you're talking about the substituents coming off, right, and in general when we're talking about chirality, one of the requirements was 4 unique substituents. This does not mean that we only look at the immediate the immediate atoms. So if I have a methyl and some ethyl group, right, even though right off of the chiral carbon, they're both carbons, that does not mean that they're not different. A methyl is not the same as an ethyl, and therefore there are 2 unique substituents. Same deal here. All right, and so we're doing RNS configuration. So we need to assign our priorities. That's the whole point. Okay, and the first thing we need to do is look at the atoms directly connected to our chiral carbon. Right. So if you can see in all of these cases, they're both carbons. Okay, all of these are carbons. So that does not tell us anything. So I'm going to cross it out. Once you cross out the carbon, you need to look at the atoms connected to it that are the higher priorities. So in the first case, on the first substituent, it's a carbonyl. On the substituent on the right, it's either our methyl or the carbon in the part of the chain, right? And so I'm skipping the carbonyl one. I'm going to talk about this one first. So we have to pick now. Are we going to focus on that carbon or this carbon? Well, again, now you have to kind of look up what's coming off of it. The methyl carbon has only hydrogens coming off of it. The carbon in the chain has another carbon coming off of it, which is a higher priority than a methyl. So we're going to just look at the CH, not this one. Okay? Over here, we're going to look at the oxygen, which is an OH, right, over the hydrogen. And over here, we can only look at the H, because there's no other choice. And here we're also talking about this oxygen. Okay? Now, which one has the priority? Now, here's the thing about when atoms are double bonded to them, okay? When atoms are double bound, we treat them as if there are two single bonds to that atom. And so what do I mean by this? So looking at the carbonyl, obviously you know that the structure has a carbonyls, double bonded oxygens and carbons. But the way when we talk about assigning priority, we almost treat this as if it looked like this. Okay? Two single bonds to that atom. All right? And so that's going to help us determine priority. So let's look at this substituent, the carbonyl, and compared to the second one, oxygen is higher than a carbon. Compared to the third one, we are now talking about an OH. Well, here we're bound to one oxygen in this substituent, whereas over here we're bound to two, as we discussed over here about how we talk about RNS when we're talking about double bonds. So what has a higher priority? Two oxygens or one? Well, it's going to be two. And so that means that this substituent is the highest priority, number one. So we know that this is going to be number one. Now, what about number two? Well, we talked about it before. It's going to be our oxygen over here. I mean, our carbon with this group right here is what I meant, right? CH2OH. So that's going to get number two. Now let's look at number three. We were talking about the carbon and the hydrogen, correct? And so between the carbon and the hydrogen is going to have the higher priority. So this would be number three. So we put the number three right there. And lastly, we have this group, which is our only one available. Put it as number four, and we put that here. All right, and so our lowest priority group here is dashed. So what we're going to do is cross it out and draw our arc from 1 to 3, 2 to 3. 2, 3, clockwise, equals R. Okay? And so I hope this video helped you guys maybe help you guys learn systematically how we determine RNS for when you get some lengthy, ridiculous molecule, right? If anything here didn't make sense, please feel free to email me or talk to a TA. If you're watching this on YouTube, make sure to, if you have a question, please feel free to comment it below so that I can answer there. And others who may have the same question can also get it answered at the same time. And I will see you guys in the next video.